Question 7. So the first thing, let's rewrite this to the power of a half. Okay, right, this is what I like to do here, is I'll just treat this just as a, like, even if that was just a whole number, right, just treat it exactly the same way. Now I'm going to write some stuff down that maybe won't make sense. So I'm going to do half C0 multiplied by this part, 4 to the power of a half, and then this part minus x to the power of 0. We're only doing the first 3 terms. Now, if you try and do half C1 on your calculator, right, it won't work. I'll show you how to do it in just a moment. And when I do these questions, always expand in this same way. Just find it really easy to do. Right? Obviously, if these are whole numbers, right, then life is a lot easier. But effectively, I'm just doing exactly the same thing. Right, there we go. Right, I've written down the first 3 parts of it. So I'm just going to write down all of the easy stuff first of all. So let's just split it up into 3 parts. So the first one, well, I can do this bit, that's 2, right? And I know that's 1, anything to the power of 0 is 1. I'm going to get a minus x there, and I'm going to get an x squared there. This one to the minus a half is a half, and then we've got an 8. Right, so the only things that we've really got to make sense of is what these mean over here. Now, you're used to the idea, which should be NCR. NCR is n factorial, n minus r factorial, r factorial. So effectively, the first one is n factorial over n factorial. So it's just going to be 1. All right. So any combination with a 0 there is always going to give you a 1. Right. So now let's try and do this one up here. So these two are obviously a little bit harder, but let me show you how to do them. So it'll be a half factorial. Now you try and do a half factorial on your calculator, and obviously it won't make sense of it. And then it's, so I'm going to have 1 and then minus 1. So then that would be minus a half factorial. Now, think about what a half factorial means. Half factorial means a half multiplied by minus a half, and so on. It's actually a half multiplied by minus a half factorial. So it's actually going to cancel, and it's just going to leave you with a half. Let's try this one. So a half C2. So that'll be a half factorial over. Now this time it'll be over minus 3 over 2 factorial and multiplied by 2 factorial. That's just 2. Right. Now let's think about what happens here. Now the top line I'm going to write like this. A half multiplied by minus a half multiplied by minus 3 over 2, carry on, so effectively it's that factorial. So over minus 3 over 2 factorial times 2. That goes with that bit. And then that's going to leave you with, that's going to be minus 1 over 8. Right, let's piece all this together. And what have we got, right? So that's 2. That's going to be minus a quarter x, and then that's minus 1 over 64 x squared. So it's better to just write that in one line. 2 minus quarter x minus 1 over 64 x squared. And the k value was the thing that we were trying to find out. And there we go. We've just found out what k is. All right. Now, it did say up here, it says plus, doesn't it? So actually k is equal to minus 1 over 6, 4. Now, the last part of the question says a student attempts to substitute x equals 1 into both sides of this equation to find an approximate value for root 3. So that kind of makes sense, doesn't it? So 4 take away 1. Right. State giving a reason if the expansion is valid. So what makes it valid? Okay. So it's only valid if modulus of x over 4 is less than 1. In other words, it's the modulus of x less than 4. What you're effectively doing is, like, you don't want to go into negatives here, do you? All right, so we need to be less than 4. So is it less than 4? Well, it's x is equal to 1. So therefore, yes, it is valid.